All right, assalamu alaikum everyone. Let's begin. Can someone please confirm if you can see my screen?
Yes, sir.
All right, so we are going to continue with where we left in the last session. We were discussing these four diagrams. So we started with the stem and leaf diagram in the last session. We discussed how to draw that and also how to draw the back-to-back stem and leaf diagram. We talked about these two things. Then we talked about the two benefits that you have for a stem and leaf diagram. Number one, that it shows how the data is distributed. And number two, it shows all data. So if you wanted to go back to the original data, you can actually go back as well because it shows all data. You can see all the values in the stem and leaf diagram. That's what we did in the last session. We also did box and whisker plots, how they are made using 5 values: minimum value, lower quartile, median, upper quartile, and the maximum value. And we did a couple of examples in that as well, especially this one where we drew 2 box and whisker plots on a single diagram. All right, so that's what we did in our last session. Now today, first of all, we're going to talk about how to draw histograms and cumulative frequency curves. And then we will see if we have enough time to do a couple of practice questions on this as well. Let's start with this then. So let's start with cumulative frequency curve today. With histogram first of all. Now this is something that you know from O-level, so I'm going to try and be a bit quick about this since you already know about it. How do we draw histograms? For histograms, there are 2 things that are going to be important. Number one, you cannot have gaps between the bars that you have on histogram. So if you remember, in your O-levels, you have done 2 types of diagrams. One was histogram and another was a bar chart. So they were very similar. So if I have a horizontal axis here like this, a bar chart could look like this, for instance. You could have one bar here, and then you could have another bar here, and then another bar here. So you could have gaps between bars like this, right? Now, histograms cannot have gaps between them. So the bars in histogram cannot have gaps between them. So that's important. If you have anything like this, looking like this, that's not a correct histogram. You can't have something like this. You're not going to have gaps between bars. Okay, that's one thing. And then on the vertical axis on a histogram, you have frequency density. All right, it does not matter whether your intervals are all equal or unequal, whatever it is, on the vertical axis, you're always going to draw, you're always going to plot frequency density and not frequency. You're not going to plot frequency there. Now, what is frequency density? For frequency density, you need to know about another thing first, and that's called class width. All right, so you have class width, that's one thing. And then using that, you will be calculating frequency density. And these are 2 things that are going to be important for drawing the histogram then. Now, let's look at this table. Let's look at this data and try to think about how to draw a histogram using this. Now, it says the following table gives the marks out of 75 in a pure math examination taken by 234 students. So we have their marks given. So, for instance, there were 40 students who got marks between 1 to 20. Then there were 56 students who got marks between 31 and 40, and so on. For example, you have 21 students who got marks between 61 and 75. All right. So if you were to add all of these frequencies, the total should turn out to be 234 because that's the total frequency. Now we need to draw a histogram representing this information. And we have this grid given. Now, this grid that you'll be given, this will be very similar to what you used to get in O-levels as well. It will be 1 centimeter having 5 small boxes. All right, so 2 centimeters is going to have 10 small boxes, right? So 1 small box here, this is going to be 1 centimeter square. Okay, so you get the same grid on the exam. Now, how do you draw the histogram? The first thing you have to do is keeping in mind that you cannot have gaps between histogram and on the horizontal axis. You're going to be drawing marks. You're going to be plotting marks on the horizontal axis. Now, if you look at the data, there are gaps between the intervals. So you have the first interval that's 1 to 20, and the next is 21 to 30. Now, assuming that the marks are in integers, yes, we might not have any marks between 20 and 21, but when we draw a histogram, we can't have gaps between the bars. So what we have to do is we have to first adjust these intervals. So what we do for that is we take the midpoint of 20 and 21 and we say the actual class boundary here is 20.5. And the next one is 30.5. And you have 40.5. Then you have 50.5. And you have 60.5 here. And then using the same pattern, you adjust the boundaries on the extreme left and on extreme right as well. So instead of 1 here, you say this is 0.5, and the extreme right there, you say this is 75.5. These are your intervals now. All right, so these are your actual intervals. You're not going to be considering 1 to 20. You will be considering 0.5 to 20.5, and then 20.5 to 30.5, and so on. Now, the first thing we need to calculate here is class width. What is class width? Class width is defined like this. For any particular interval, for any particular class width is defined as the upper boundary of that class minus the lower boundary. This is how class width is defined. All right, upper boundary minus the lower boundary. Let's look at this data. What we're going to have to do is we will need to add another row to this data, which represents class width. Now, it's not necessary that you add this here because you're not going to need class width for plotting values, but frequency density will be needed. You can write class width here if you want, or just add a row for that. That's your choice. Let's say if I were to add a row for that represents class width, it'll be something like this. CW, that stands for class width. Now, how do I calculate class width? It's not going to be 20 minus 1. It's going to be 20.5 minus 0.5. That's how I would need to calculate my class width. For the first class, the width is 20. Then 30.5 minus 20.5, which is 10. 40.5 minus 30.5, that is also 10. Then 10 again, 10 again, and then finally for the last class, I have 15. These are my class widths. All right. And now I would need to calculate frequency density, which I'm representing by FD here. What is frequency density now? Frequency density is defined like this. It's frequency divided by class width. All right, so in short, we could write it like this. Frequency density is equal to frequency over CW, which is class width. That's how frequency density is defined. So for every interval, you're going to take the frequency, divide that by class width, and that will give you frequency density. So for the first interval, for instance, we have 40 divided by 20, which gives us 2. 34 divided by 10, that's 3.4. And so on. 56 over 10 is 5.6. 54 over 10, that is 5.4. 29/10 is 2.9. And then finally we have 21/15, which is going to turn out to be 1.4. So these are all frequency densities. All right, this is what we're going to have to plot on the vertical axis now. So this is one row that is important. On the horizontal axis, we're going to have this. And then using these values, we will just draw those bars. Now, vertically, the maximum value we need is 5.6. So you can take the scale, keeping that in mind, that you have to go up to 5.6 at max. Horizontally, we are going to go up to 75.5. So let's say I start from here. Let me draw a vertical axis here. From 0.5 to 20.5, and then 20.5 to 30.5. Rather than starting from 0, it's actually going to be a good idea to start from 0.5 those values. So rather than having 0 here, for instance, a better idea would be to not start from 0 on the horizontal axis, and instead have a break like this, and then start from 0.5, and then you have 10.5 and 20.5 and so on. All right, now let me just fill this. I'll take a break of 1 minute. There's a design going on here. I'll just fill all of these values here. In the meantime, using this scale. All right, let's resume. So it's really important to label these axes properly. We've got marks here, frequency, density here. And then on the horizontal axis, see what I've done? I've not started from 0, because if I started from 0, I would need to have 10 here, and then 20 here, and then 20, and then 30 here, and 40 here. But the values that I have to plot, they are actually like this: 0.5, 20.5, 30.5. And that will actually make it difficult for me to plot all of those values, because 0.5 will be half a box in that case, right? So you'll have to have half a box here like this, and that will make things very tedious. So it's much easier to start your scale like this, since your values are starting from 0.5, and then the intervals look like this, that you could take a gap of 10, and that will keep all of these values on these main lines that you have on the graph paper. All right, so instead of starting from 0, it's a better idea to do it like this: 0.5, 10.5, 20.5. Every 5 boxes here are still representing 10 units, but we have just changed what the point that we have started from. Okay. Now let's just draw this histogram now. So for the first interval, we have 0.5 to 20.5. What's the frequency density for that? It's 2 units. So from 0.5 to 20.5, we have a frequency density of 2. Let's draw that first of all. We draw a bar there from 0.5 to 20.5. It has a height of 2 units. So it looks like this. All right, so that's the first part that we have. Then the next one is from 20.5 to 30.5. That's 3.4. Frequency density is 3.4. So we draw a bar like this for that, 3.4. And the next one is 5.6. From 30.5 to 40.5. This is the next bar. All right. And the next one is 5.4. That looks like this. Then you have 2.9 after that for 50.5 to 60.5. $2.9. That's going to be here. And then finally, the last one is from 60.5 to 75.5. And the frequency density there is 1.4. So that is going to look like this. This is what your histogram looks like. All right, so that's what you were supposed to do here. On the vertical axis, you have frequency density. On the horizontal axis, you have marks, and that's how you draw this histogram. All right, so this is how we draw histograms. So we have to adjust class intervals. That's the first thing we have to do. Adjust the class intervals. Then find class width. Using class width, find frequency density. And then just plot those class intervals along with frequency density on your diagram like this. Okay, so this was 5 marks. Doing all of this. This is how your histogram looks like. All right, let's move on. Now, how do we draw cumulative frequency curves? Let's think about that now. Cumulative frequency curves. That's the last type of diagram that we have now. Cumulative frequency curve. Let's see how we draw this. Let's say we have this table given, number of rooms occupied, and we have the corresponding frequency given for each of these intervals that we have. All right. Now, how do we draw this cumulative frequency curve? Let's think about this. So it says the number, so it's probably data about some hotel. And for that hotel, we know that the number of rooms occupied between 1 to 20 is 10. Yeah, so let's say this is data about a hotel in which you have data on different days. So that maybe, for example, there were 10 days on which 1 to 10, 1 to 20 rooms were occupied. There were 32 days on which 21 to 40 rooms were occupied. There were 62 days in which 41 to 50 days were occupied, and so on. Now, what you need to do is you need to draw a cumulative frequency curve to represent this information. All right. So now, how do we represent this information? Let's think about this. Now, here you have to make a slight distinction. Basically, what happens is sometimes the data that you're given is continuous, and sometimes the data that you're given is not continuous. It's discrete. So, for example, in this case, we're talking about number of rooms. Think about whether you can have decimal values for number of rooms or not. Number of rooms is a discrete variable, right? Number of rooms is a discrete variable. Number of rooms cannot be in decimals. So when you are basically drawing a cumulative frequency curve for data sets which are discrete, you are not going to adjust it like this. So you won't say that this is 20.5 and this is 40.5, this is 50.5. For a histogram, you need to do that. For a histogram, you need to do that. But the problem with that is that histograms cannot have gaps between them. However, for cumulative frequency curves, remember, the first thing we need to do is we need to find cumulative frequencies. So we need to find cumulative frequency here. We need to add another row here that represents cumulative frequencies. But in that row, since that row is going to correspond to some inequality on top, for example, for the first interval, if it says 1 to 20, we would write it as less than or equal to 20. And we could say cumulative frequency for that is 10. Now, the point that I'm trying to make is you are not going to write it as 20.5 here. You will just write it as less than or equal to 20. If this variable was something else, something other than rooms occupied, so maybe if they were talking about time, for instance, or they were talking about length of something, now these variables would be continuous, which means they could also have values which could be in decimals. In that case, you would need to adjust this interval to 20.5 instead. So in that case, rather than plotting 20 on the graph, you would be plotting 20.5 if you had a continuous variable. But since in this case, we have a variable that is discrete, number of rooms. Number of rooms cannot be in decimals, right? You can only have an integer number of rooms. For that reason, when we are drawing a cumulative frequency curve, we are not going to adjust these intervals for data sets like this. This is a discrete data. We are going to use less than or equal to 20, less than or equal to 40, less than or equal to 50 here, less than or equal to 60, less than or equal to 70, and less than or equal to 90 here. We are not going to adjust these intervals in this particular case because we have a discrete variable. For continuous variables, we would adjust these intervals. All right, I hope that makes sense. So anything that could take a decimal value as well, length, time, etc. For that, you would instead write 20.5, 40.5, 50.5, etc. All right, but that's not the case here. So that's the first thing that you do. You first adjust these intervals like this. You write them in less than or equal to form. Okay. And then you add another row to the data that represents cumulative frequencies. Now, what are cumulative frequencies? Let's think about that. We are not looking at those intervals anymore. From 1 to 20, 21 to 40, we are instead looking at these inequalities. Now, what's the total frequency that is less than or equal to 20? That is just 10 in this case. However, what about the total frequency less than or equal to 40? Now, towards the left of 40, you have this frequency and also this frequency. What's the total for both of them? That's 42. That would be your cumulative frequency that you write here. Then similarly, the next value is less than or equal to 50. Now, towards the left of 50, you have all of these three values. So what's the total frequency to the left of this? That will be the cumulative frequency on the left side. That will turn out to be 10 plus 32 plus 62. You add all of those numbers, or you could just add 42 and 62. That is going to give you 104. And then you think about all the values less than or equal to 60. That would be the sum of all of these values. Or you could just add the previous sum to 50, and that is going to give you 154. And then 154 plus 28, that would be 162 and 182. And then 182 plus 18, that's 200. So this is the first thing that you do for drawing a cumulative frequency curve. You add a row to the table that represents cumulative frequency. All right. And you have intervals like this. And now on the diagram, you're going to plot these values. These represent the number of rooms occupied. And cumulative frequency, this is going to be on the vertical axis. So you're going to plot all of these points now. So one point would be 20 on the horizontal axis, 10 on the vertical axis. Then another point would be 40 on the horizontal axis, 42 on the vertical axis, and so on. All right, let's draw this cumulative frequency curve now. Now, what do we need on the horizontal axis here? Number of rooms. Now, they're going from 0 to 90 on the horizontal axis. Let's draw that here. So again, it's important to label these axes, number of rooms. On the vertical axis, we have cumulative frequency. Now, on the vertical axis, it's important to always start from 0. Horizontal axis could start from anywhere. That's your choice. Like in the last example, we started this from 0.5. But the vertical axis has to start from 0. This is important. You can't start vertical axis from another number, because otherwise it just distorts the shape of the graph a little. So you're not going to do that. Vertical axis will always start from 0. All right, but horizontal axis can start from a different number if you want, but that's not necessary. Okay, so in this case, we could start from 0. That will work. That will work just fine. On the horizontal axis, we could have 0 here, then 10, 20, 30, 40, 50, 60, 70, 80, 90. And on the vertical axis, we need values up to 200. So we could have a scale like this here, 20, 40, 60, 80, 100, 120, 140, 160, 180. And apparently the values are not going to complete here. So what we could do is we could just take it down a little. So you should actually make this calculation before you start drawing them. I can actually move it around, but you can't on your paper. So count the boxes before you start writing down the values. So in this case, you have 200 here now, and that is your vertical axis. Now, again, you label the axes. On the horizontal axis, you have number of rooms. On the vertical axis, you write its cumulative frequency. Remember, on a histogram, you have frequency density. Always on a cumulative frequency curve, you always have cumulative frequency on the vertical axis. Now you just need to plot those values and join those points using a curve. What's the first point now? 20 and 10. 20 on the horizontal axis, 10 on the vertical axis. So that's this point. All right. Now you always add another point here, and that is that at 0, you have 0. So cumulative frequency would actually be 0 here when the number of rooms occupied is less than or equal to 0. So you always join this line with the x-axis, with the horizontal axis. In this case, it's going to start from here actually. At 40, you have 42. So that will be somewhere around here. And then at 50, you have 104. And that point will be here. At 60, you have 154. 150, so that's going to be somewhere around here. At 70, you have 182. And that will be this point. And then finally, at 90, you have 200. These are all the points that you have. Now, using these points, you're going to draw a curve, a smooth curve, which will look like this. So you'll always do this using a pencil because you can't draw it correctly the very first time generally. So you need to erase it, improve it a little. So it might look something like this. This is what the curve looks like, right? This is the cumulative frequency curve, and that's how you draw it. Now, you might find in some older marking schemes that they would have drawn straight lines through these points like this, straight lines through these points like this. But please know that that is not allowed anymore. They used to allow that until a couple of years back. They used to allow drawing straight lines, but that's not allowed anymore. You have to draw a curve. Just like you used to draw curves in O-levels, here as well, it's necessary to draw curves. They do not allow straight lines anymore. Okay, so please don't just look at some of the older marking schemes because they used to allow that earlier. They don't anymore. All right, so you have to draw a curve like this. This is how a cumulative frequency curve looks like. Now, using this curve, you can do a number of different calculations if you had to. For instance, you can find the median of these values. You can estimate the median of these values. How would you do that? Median is given by n over 2th value. Remember, in group data or from cumulative frequency curve, we calculate the median using n over 2. What's the total number of values? 200. So we could say 200 over 2, that's 100th value. 100th value is going to give you the median. So what you're going to do is, on the vertical axis, you will go at 100. This is 100, right? And see what value it gives you on the horizontal axis. So you just go here on the curve. On the horizontal axis, this is giving me a value which is just before 50. You could say it's 49. So median is 49 here. Similarly, you could find the lower quartile, which would be the value that you get at 50 here. Upper quartile would be the value that you get at 150 here, 3n over 4, right? So that will be the value at 150 and any other percentile. So you might be asked about the 10th percentile, 60th percentile, whatever that is. If it's 60th percentile, for instance, all you have to do is 60 multiplied by 60 over 100 multiplied by whatever the total number of values is. That's 200 in this case. And you would look at what is the value at 120. So 120 is here. you can see whatever the corresponding value on the horizontal axis is. So everything else works the same way as it used to in O-levels here as well. All right. So if you had to find the interquartile range, you would find the upper quartile, subtract from that the lower quartile, and that would give you the interquartile range. So you can do all of those calculations for median, lower quartile, upper quartile from this graph. All right. I hope this makes sense. Let me know if there are any quick questions on this, and I'll do an example on this quickly then. All right, so if there are no questions, let's actually look at this. Let's look at this example. So you have two cumulative frequency curves shown here. You can see them on the diagram. It says the birth weights of random samples of 900 babies born in country A and 900 babies born in country B are illustrated in the cumulative frequency graphs. So you can see the cumulative frequency graphs for two countries, country A and country B. There are 900 babies in total in both of those countries, for which you have the data. Now it says use suitable data from these graphs to compare the central tendency and the spread. Spread means dispersion, right? Dispersion or variation in data of the birth weights of the two sets of babies. All right, so you have to compare central tendency and spread dispersion of the data. Now, how do we do that? It's 6 marks, right? Now, a cumulative frequency curve can give you the median. So for the central tendency measures, you can't find mean from the curve, right? That's not possible. You can't find mode from the curve. The only central tendency measure that you can find from the curve is median. So that is what you're going to calculate to compare the central tendency, median of both the graphs. You can compare the medians. And the second thing that you're going to compare is the interquartile range. That's the other thing that you use a cumulative frequency curve for. You can find the interquartile range from this graph as well. Okay, now let's try and do this. Let's see how we can calculate all of those things from this data. So you have data about two countries. So you can see here the key that is given, the solid line, the solid curve that you have, that's for country A, this one, and the dashed graph, that is for country B. Now let me write here on the side, we have country A and we have country B. We can just look at this graph now, find the median first of all, and see what that turns out to be. Median for A and B. We have 900 babies in total. How do you find the median? 900 divided by 2, that gives you 450. So 450th value is going to give you the median. So on the vertical axis, you look at where 450 is. This is where you have 450. You can see where the graph is at that point. So when you have 450 on the vertical axis, on the horizontal axis, you have this value. And this is 2.05. So that should be your median for country A. Similarly, you can see the value that you get at 450 for country B. For country B, I'm getting this value. It's between 3.8 and 3.9, which is 3.85. So median for country B is 3.85. That's one thing that we can calculate from this, right? So this is going to give us a central tendency measure, that's median. And for spread, which is dispersion in the data, we could calculate the lower quartile and the upper quartile and then use those values to find the interquartile range. Let's do that now. Let's find the upper quartile and the lower quartile, and then use both of those to find the interquartile range for both countries. Let's find upper quartile. So how do you find upper quartile? For upper quartile, you do 900, or let me just write that after that. So 3n over 4, so that's 3 into 900 over 4. That's going to give us 625, I think. Yeah, 620. No, not 625. It's going to be 675. 675th value, that's going to be your upper quartile. And then for the lower quartile, you could use n over 4, right? So I'm just using those formulas if you remember, which I told you about earlier, that we use for group data or on cumulative frequency curve. These formulas for lower quartile, we use n over 4. For median, we use n over 2. For upper quartile, we use 3n over 4. All right, so that's what we're doing here. So we have the upper quartile, that's going to be at 675th position. Let's figure that out first. 675 is going to be somewhere here, very close to 680. Let's see what value we have here. This is 2.4. That's the upper quartile that we have for country A. Then for country B, that turns out to be 4.5. Lower quartile, for lower quartile, we would need to calculate 900 over 4, n over 4. That gives us 225th value. 225th value is going to give us the lower quartile. Now let's go back to the graph. 225th value is going to be somewhere around here. And this is 1.5 for country A. For country B, it's going to be somewhere around here, which is coming out to be 2.15 for me. Okay, so this is 2.15. So I've got all of those values from the graph that I need. Now upper quartile minus lower quartile, that gives me interquartile range, which is 0.9 for country A. And for country B, it's 4.5 minus 2.15. That's going to be 2.35. This is the data that I need now. And now I can compare the birth weights using central tendency and spread of birth weights of the two sets of babies. What can I say using this? I can say, on average, birth weights of babies in country B are higher. All right, so on average, so median for country B's babies' weights is higher as compared to babies in country A. And also, there is more variation in these weights. Interquartile range is also greater. So variation in the weights of babies in country B is also higher as compared to the variation in baby weights of country A. So we can just write those two statements down here. We can say, on average, why are we using the word average? Because we're talking about median here. Median is one way of calculating average. On average, birth weights are higher in country B. That's one observation. Number two, what about the spread? The variation in birth weights is also more in country B. You see, its variation is also greater. That these are the two statements that you could write here. All right, so on average, birth weights are higher in country B, and also the variation in birth weights is also greater in country B. Does that make sense to everyone? Any problems with this? Any questions? No problems? Any questions on any of these things?
Sir, is it just possible for you to upload this video today? I'd just like to go over it again.
Sure. Just leave me a reminder on your group today as well. I'll do that.
Thank you.
All right. Okay. What I'll do is I'll just do one quick question before we end, because in the next session we're going to be starting our next topic. Let's just do one quick question. So if there are no questions from you guys, let's just quickly try this. This is question number 48 from the worksheet. Let's quickly have a look at this. All right. I'm not going to do all parts of this. You can skip the first part. I'll just tell you the values that we need for that, and then you can do the rest of it. But I want to actually focus on the third part in particular. That's a bit tricky to understand initially. All right. So it says the cumulative frequency graph shows the annual salaries in thousands of euros of a random sample of 500 adults with jobs in France. It has been plotted using group data. You may assume that the lowest salary is 5,000 euros. You can see that lowest salary here. And the highest salary is 80,000 euros. That is somewhere here. Okay. On graph paper, draw a 𝗺𝘁𝗵𝗵𝗵𝗹 plot to illustrate these salaries. You remember what values do we need for a 𝗺𝘁𝗵𝗵𝗵𝗹 plot? You can actually just draw that afterwards. There are 5 values that we need for that. Minimum value, they've told us what that is. The minimum value is 5,000. You need the lower quartile, upper quartile, or before that, you need the median. You need the upper quartile, and you need the maximum value. They've also told you what the maximum value is. That's 80,000. So you know the minimum, you know the maximum. From the graph, you can figure out the rest of the values. The total number is 500. There are 500 adults. Median is going to be at 250. You can see that number is somewhere around here. That's 19,000. In fact, 18,000, because the scale is like this. This is 10, this is 20. One box would represent 2,000. So median at 250 turns out to be 18,000. You can write that here. Then lower quartile, again, 500 over 4. That's going to be where the lower quartile is, which is 125th value. You can see what the value is at 125. At 125, you have 15,000. That's your lower quartile. All right, so this is going to be a lower quartile, 15,000. And the upper quartile is going to be 3 into 500 over 4, which is 375th value. On the diagram, see where 375 is. That's here on the vertical axis. On the horizontal axis, it becomes this value, which is 26,000. You have these 5 values and you can just draw a box and whisker plot using these values. All right, so that's pretty straightforward that you can do. Look at the second part. It says comment on the salaries of the people in this sample. Now, when you've drawn the box and whisker plot, you would see this is how the distribution looks like. So you can see most people have salaries in this region between 5,000 and 26,000. And then there are very few people who have salaries above 26,000. So the highest is 80,000, but you can say most people have salaries. So that's like 75% of people. So one comment could be something like this: 75% of people have salaries less than $26,000. Why? Because remember, upper quartile, what does that represent? It represents the 75th percentile. So most of the salaries are actually below this number. But then there are some people who are earning more than 26,000, and it's going as far as high as 80,000 for some of them. All right. So this could be one comment, that 75% of people have salaries which are less than $26,000. All right. That's just a 1 mark, and that should be okay. Let's look at the third part of this. That's what I want to focus on. It says an outlier is defined as any data value which is more than 1.5 times the interquartile range above the upper quartile, or more than 1.5 times the interquartile range below the lower quartile. How high must a salary be in order to be classified as an outlier? Now, it's really important to understand the statement correctly. Outlier generally is a data point that is far away from the rest of the values, right? In this case, they've given us a specific definition of an outlier, which can be used in this particular question. And that definition is, it's a value that's more than 1.5 times the interquartile range above the upper quartile. So if you were to start with the upper quartile, one definition of outlier is that if you start from the upper quartile, if you have a value that is more than 1.5 times, so plus 1.5 times the interquartile range, if you have a value that is greater than this number, upper quartile plus 1.5 times the interquartile range, then that salary is an outlier. So let's say if you were to denote salary by X, what's the condition for being an outlier? That value should be upper quartile plus 1.5 times the interquartile range. This is the minimum that it should be. What's the upper quartile? Do we know that? We found that in the first part. That was 26,000. Plus 1.5 times the interquartile range. What's the interquartile range? It's 26,000. Let me actually calculate that on the side. Interquartile range is 26,000 minus 15,000, which is 11,000. So 1.5 times 11,000, and that gives you 26,000 plus something here. What's that? 16,500, and that will turn out to be 42,500. So in order to be classified as an outlier, the salary would need to be greater than 42,500. That's what it means. right? So this is what we're using. More than 1.5 times the interquartile range above the upper quartile. So how high must a salary be to be classified as an outlier? If you're looking at the upper side, on the upper side, this is the condition that we have, that it should be greater than 42,500. Now, what about the other side? In part B, they've asked about what happens on the lower side. So it says, show that none of the salaries is low enough to be classified as an outlier. So what's the condition on the other side here? The other condition is that salary could also be an outlier if it's more than 1.5 times the interquartile range below the lower quartile. So on the lower side, what's the limit? On the lower side, the limit is that the salary should be, on the lower side, the limit, the condition for an outlier is that the salary should be less than lower quartile minus 1.5 times the interquartile range. So basically, you have some lower quartile, you have to be 1.5 times the interquartile range below than that. So how would you calculate that? Lower quartile's value minus 1.5 times the interquartile range. Now, what's the lower quartile? The lower quartile is 15,000. Let's write that down here. 15,000 minus 1.5 times the interquartile range, which is 11,000. And that is going to give you minus $1,500. So a salary to be classified as an outlier on the lower side would have to be less than minus $1,500. Now, that does not make sense because salary cannot be negative. Now, since salary cannot be negative, that means there are no salaries that can be classified as outliers on the lower side here. Okay. And in this case, you already know that the lowest salary is 5,000. So even if it was a positive number, but less than 5,000, then you would have no salary that would come in this range. So there's no outlier in the data on the lower side. There are some outliers on the upper side because the upper salaries are going up to 80,000, right? But the lowest salary is 5,000. So the condition for outlier is not met on the lower side. There are no salaries which can be classified as an outlier on the lower side. All right. So that's what you do in the last part here. Does this make sense? Any questions on this? Because that's it for today then. If there are no questions, tomorrow we will be starting discrete random variables. That's our second last topic. If you have any questions, let me know. Otherwise, we are going to end this here. And we'll continue this tomorrow, inshallah. No questions, anyone? All right, good. So that's it for today. I'll see you again tomorrow. Allah Hafiz. The P3 class is going to start in about 10 minutes from now, okay?